All right, so 7-4 is matrices and systems of equations. So now we're going to learn a fourth way to solve matrices of to solve systems of equations, which is using matrices. This is where there's a big gap between Algebra 2 regular and Algebra 2 honors, because Algebra 2 regular does not go to the level that Algebra 2 honors does. So for at least for the next couple of days, if you're in honors, be patient because we're going to go through it slow. And if you're in regular, don't freak out. You've got some time to practice it, okay? So a matrix is a rectangular array of numbers with m number of rows and n number of columns. And you get something called the order of the matrix or the dimensions of the matrix, because you'll see those interchangeable. And it's the number of rows and then a little x for by the number of columns. So just like you would say length and width as a dimensions, we say rows and columns. So if I was looking at this matrix, I would literally just count 1, 2, 3 rows, and then 1, 2 columns. So the rows go left, right, they're horizontal, and the columns are up, down. Think columns hold up houses, right? Columns are up and down. And then if you think about like the overlap on a numbers or Excel spreadsheet, the same thing, right? Rows are horizontal and columns are vertical. So that's how you would write the order of the matrix. Number of rows with an X, number of columns. So example 1 just asks for that. Find the dimensions of the matrix. So if I ask you for the dimensions of the matrix on A, you would tell me that it's what? 2 by 4. And B would be 3 by 1. Okay. So you're not going to, God bless you. You're not going to get a test question that asks you for the dimensions, but you do need to know that so that 1, we know what we're doing when we move forward. 2, you're going to see this a lot in multiplication of matrices, which is in 7-5. And then also, I'm going to teach you how to do the matrices in your calculator. You need to know the order there. All right, so the augmented matrix is writing only the coefficients and constants that appear in an equation. So if I have an equation that says negative 2x plus 3y equals 7, x minus 4y equals negative 10, then I'm going to go in order. It's going to be x's, then y's, then the constants, and you leave out the variables. So this would be negative 2, 3, 7, 5, negative 4, negative 10. And this is called an augmented matrix. So there's no variables in there. Sometimes you'll see 2 little dots, like a colon, in between the variables and the constants. You don't need them there, but if you see them, that's what they're for. If there's 3 variables, it goes x, then y, then z, and then the constant. If there's 4 variables, don't ask me why, it goes x, y, z, w, and then the constant. Apparently 4 goes out of alphabetical order. Don't know why, but that's what happens with your variables if you see it with 4. All right, so example 2 just says write the matrix from the system or vice versa. So what would be the first row of A in your matrix? 7, 4, negative 1, 10. Second row, 1, negative 5, 0. You have to have the placeholder there, 17. And again, you can put the 2 little dots to separate them out. You don't need them. Now on B, notice, again, they don't have the dots. This is your constant, which means this is your x, this is your y, this is your z. So I'd get negative 7x plus 2y plus z equals 4. And then 5x minus 3y. There's no z, so I don't need the 0, equals 15. So you got to know how to get both forms. From matrix into equation form, because we use this with back substitution, or equation into matrix form, because that's how we're going to solve them. Easy stuff so far, right? Questions? All right, so these are all the things you can do to a matrix. There's 3 things. You can switch rows, so I can move row 1 to row 3 and 3 to row 1. I can literally switch the rows. I can multiply by a non-zero constant, so 0 would cancel everything out. You're not going to multiply by 0, but you can multiply by anything else. And you can add a multiple of a row to another row, or just add 2 rows. Because if it's not, a multiple of 1 is the same thing as another row. As adding 2 rows. So we can add, we can multiply, we can switch. Okay, example 3 says identify the elementary row operations being performed to obtain the new row equivalent matrix. So if this is my original matrix here, and this is the result, the question is what changed, right? And how do I get there? Row 1 stayed the same, right? But row 2 changed. So I didn't switch them. Can you multiply 3, -1, and 2 by the same number to get 14, 0, and 13? No, so I didn't multiply. If I add the 2 rows, I get 5, 3, 7. That's not it, which means there's some combination of them, right? So what can you do to get 14, 0, and 13? To be honest, I would start with the 0. That's the easiest. How would I cancel out the y's? So I'm going to multiply something by one of the rows and then add them together.
Multiply -1 by 4.
So multiply row 2 by 4. Let's see if it works. 12, -4, 8, plus 2, 4, 5. And I get 14, 0, 13. There it is. The way you write it is 4 times R2 plus R1, or R1 plus 4R2. This is called row operations, and you're going to have to show them. So I said it when you did your systems of 3 variables, 3 equations. You have to tell me what you're doing when you're doing it. That's what it will look like. So if I ask you what row operation you did from the original to the new, you can write either of those. 4 times row 2 plus row 1, or row 1 plus 4R2. It doesn't matter which way you do it. But that's called your row operation. Questions so far? Okay, this says fill in the blanks using the elementary row operations to form a row equivalent matrix. So first you got to figure out what change was done and then do it to the term that's missing. So did the top row change? No, which means eliminate the switching, right? Can you multiply something on the bottom to get the 2 that are already there? Good. So normally, like we say, oh, we're going to divide by 5, but technically you can't divide a row in a matrix. So instead we multiply that by the reciprocal. So if I took this and multiplied by 1/5, 5 times 1/5 is 1, 7 times 1/5 is 7/5. So if I did negative 10 by 1/5, I get -2. That's when it's going to fill the remaining spot. Questions so far? I'll be honest, you still have not gotten to a quiz or test question. Okay, so all of this is building blocks for what we're going to do. But you need to know how I'll do all this before we keep going. Everybody's good? Yes? Okay. So there are 2 types of forms that our goal is to change our matrix into. And the first is RowEchelon. The second is going to be reduced RowEchelon. RowEchelon means that you have a diagonal of 1s with a 0 below them. So if it's a 3 by 2 matrix, those diagonal of 1s are going to be in that location, and the 0 is going to be under them. You can have numbers here, so there can be 1, 2, 3, whatever numbers are there are fine. If it's a 3 variable equation, then it's going to look like this. You need a diagonal of 1s here, and again, 0's below it. But there will be numbers here, 1, whatever numbers are here, 4, 5. All of those will be numeric. That's called RowEchelon. So by definition, it says any row consisting entirely of 0s can occur at the bottom. So you can have a row of all 0s. It just has to be all the way at the bottom. And then for each row that does not consist entirely of 0s, the first non-zero entry is 1. So if I'm moving from left to right, the first number I hit that's not 0 has to be 1. So notice this is 1, this is 0, but this is 1. This is 1, this is 0, but this is 1, 0, 0, this is 1. So that's where that diagonal of 1s comes from. The third thing says for 2 successive or non-zero rows, the leading one in the higher row is further to the left than the leading one in the lower row. That's where that diagonal comes from. So the diagonal needs to run from top left to bottom right. Okay, I can't switch these rows and have it still be in RowEchelon form. I can switch them, but then it's no longer in RowEchelon form. And that's going to be our first goal. Reduced row echelon form has the diagonal of ones, zeros above and below it. So now whatever's on top of that diagonal also has to be a zero. Whether it's 3 variables or 2, above and below my diagonal has to be zeros. So again, one's row echelon, one is reduced row echelon. And then from there, you're going to solve using 2 different methods, which you'll see in a minute. But you need to know the difference between those. So row echelon, diagonal of ones, 0 just below. Reduced row echelon, diagonal of ones, zeros above and below. These will always be constants. Okay? They can be fractions, they can be positives, they can be negatives. But they will always be just, and they could even be a 0. Okay? Because x could be 0, y could be 0, z could be 0. But those will be numeric. All right, so this says determine whether the matrix is in row echelon form. If it is, determine whether it's in reduced row echelon form. So the first thing is you're looking for a diagonal of ones with no 1 to the left of that diagonal. Is that the case? I have a 0 in my diagonal, but if you remember it said if there's a row of zeros, it just has to be in the bottom. Is that row of zeros in the bottom? Yes. The other ones have zeros to the left of them, right? There's no numbers in these spots. So this is in row echelon form. The second question is if it's in row echelon, is it in reduced row echelon? And for that, you have to have that diagonal of ones, and the zeros have to be above and below it. So I got a 0, a 0, a 0, but there's a 1, which means it's not in reduced row echelon. Do you understand the difference? Yes? 2 nods. Fantastic. I'm going to say that's a yes. Yeah. Okay. So here we go. The goal for these, for now, and then we'll take it to the next step, is to get it in row echelon form. Now, I'm going to teach you a pattern, but it's not always this way. For the most part, I try, like when I'm solving these, I try to do it in the pattern I'm about to show you. Sometimes it doesn't work, and you got to be able to, like, it's like a puzzle. It's like solving a system, okay? You got to be able to move things around. But for me, my goal is step 1, get a 1 in this location. If that was not a 1, so let's say that I had -2, -1, -2, -10, 1, 1, 0, 5, 3, 6, 7, 14. Let's say it started like that, then I would switch these to begin with. I would avoid fractions for as long as you possibly can. Sometimes you can avoid them, but for the most part, try to avoid them for as long as you possibly can. So that 1 is already in that spot, right? Now my goal, for me personally, again, it's not always like this, but I try to work the zeros down. So I find the 1 in the top left corner, and then I want to get a 0 where that -2 is. So can I add a row to row 2 to cancel it out to get a 0 in that spot without changing any rows? No, there's not another 2 in the X location, right? But what can I do so that one of those rows becomes a 2? Okay, so I'm going to do 2 times row 1, and I'm going to add it to row 2. And I get 2, 2, 0, 10, -2, -1, 2, -10. Then I'm going to add it. So I get 0, 1, 2, 0. Now that row, whatever 2 I combine with, the result can replace either of those 2 rows. So I can take this new row and I can put it here, or I can put it here. Where do I want to put it? Second row. So I'm going to rewrite the matrix. 1, 1, 0, 5, 0, 1, 2, 0, 3, 6, 7, 14. Now, again, this is just the pattern I would suggest. It doesn't always work, but then I would work my way down again. I would want a 0 where the 3 is. How could I get a 0 where that 3 is? I have to use the first row. There's no way I can change the second row so that that 0 becomes a 3, right? I can't add to a matrix. I can only multiply and add. So I would take the first row, multiply it times -3. -3, row 1 plus row 3. So now I'm taking this and multiplying it times -3. -3, -3, God bless you. 0, -15, and 3, 6, 7, 14. 0, 3, 7, -1. And because I used row 1 and row 3, I can replace either of those. But which one did I want to replace? Row 3. So 1's going to stay 1, 1, 0, 5. 2's going to stay 0, 1, 2, 0. 3 becomes 0, 3, 7, -1. Now I need one more 0 here before I worry about the 1 in that row. What happens if I combine 1 and 3? What do I lose? First of all, I would multiply by -3, but then what happens? If I do -3, 0, -15 plus 0, 3, 7, -1, I lost my 0 I just got. So when you go to find this last 0, you have to use row 3 and row 2. You cannot use row 1. Does that make sense? Okay. Otherwise, you lose what you just went to find. Okay, so now I'm gonna, because I want to get rid of that 3, what do I have to multiply by? -3. So -3, row 2 plus row 3. Pity laugh if I ever heard one. All right, -2. No, -3. I'm going to do it again. -3 times row 2. 0, -3, -6, 0, 0, 3, 7, -1. And that's going to replace row 3. So 1, 1, 0, 5, 0, 1, 2, 0, 0, 0, 1, -1. So again, my advice is to work your way through the zeros before you worry about the ones in the rows. Because if you get 1 0, try to change the 1, and then go get the other 0, you might lose that one you already found. So I do have my row, my diagonal of 1s, right? And I've got 0s below, which means that this is in row echelon form. It's not in reduced row, but my goal here was to only get it into row echelon form. You with me so far? Yep? Okay. All right, so let's say that this was given to you, right? This is a matrix. If I had written this in equation format, what would it be? What's the first row going to give you? X equals -3. What's the second row going to give you? Y equals 5. So if I get a matrix, and this is just the X and Y, but if I get a matrix in reduced row echelon, because there's zeros above and below, then I can easily grab the solution from it. This is the reason we do the whole form of reduced row. Once it's in that format, you could literally just take the equation out of it, and it will be the answer to your system. All right, so Gaussian elimination with back substitution is one of the 2 methods you're going to learn in this section to solve a system. You already learned all the hard parts. You start by writing it as a system of equation, which we know how to do, then use the elementary row operations to get it into row echelon. Row echelon is your diagonal of 1s, right? Your 0s below. Then you write the system of linear equations, so you're going back to equation form, and in that case, you'll get a triangle system, which we know how to solve with back substitution. So if you get it into row echelon, not reduced row echelon, but row echelon, you're going to get the first row has an X, a Y, a Z, second row has a Y, a Z, and the third row has a Z. From there, you can work your back substitution. So this was example 6, right? We got it into row echelon form. So if I take my row echelon form and I rewrite it as equations, it's going to be X plus Y, there's actually no Z, equals 5. Then it's Y plus 2Z equals 0. Then it's Z equals -1. So normally there's a z there, and this looks like your triangle system. This time it's not, but I already have one row solved for one variable, so I know that z is -1. Then I'm going to take that and plug it into the second line. Y plus 2 times -1 equals 0. Y minus 2 equals 0, and y equals 2. There's my second variable. Now I take that. Normally I plug in both, but I only have two variables this time. X plus 2 equals 5, and x equals 3. So RowEchelon goes with back substitution, and you will see it's called Gaussian elimination with back substitution, okay? That's the method. We get it into RowEchelon, and then we do back substitution to solve it. Clear? Yeah? Okay. Okay, I said it before, there's more than one way to do these, but what is the first thing? I would say you already have the 1 in the top corner, right? So I want to get the 0 where that 2 is. How can I do that?
Multiply by -2.
Okay, row 1 by -2 and add it to row 2. So -2, -2, -4, -14, 2, 1, 8, 0, -3, -6. That's going to replace row 2 because row 1 was already fine. So 1, 2, 7, 0, -3, -6. Now I need a 1 here. If I add it with row 1, I lose the 0, so I don't want to do that. When you get to the point that the only thing you need left is the 1, what are you going to multiply by? How could I make -3 become +1? The reciprocal, right? So I'm going to multiply by -1/3. So -1/3 times R2, and I get 0, 1, and 2. That's going to replace row 2. And because it said Gaussian elimination with back substitution, I stop there as far as the matrix goes. I have my diagonal of 1s and then the 0 below it. So from here I get x plus 2y equals 7 and y equals 2. Take the 2, plug it in here, x plus 2 times 2 equals 7, x plus 4 equals 7, and x equals 3. And my solution is 3, 2. Questions on that one? Also still not to test questions. Yeah, but again, learning a process. So let's say you have a systems of equations, 2 variables, 2 equations. You can now choose 4 methods. You could choose elimination, substitution, graphing, or Gaussian elimination with back substitution, okay? I don't know if I would ever choose that one over the other ones if it were me, but you do have that option. And obviously on a test, it's going to tell you you have to use one of those methods, okay? All right, I think this is... So easiest, I would say, is if there's a 1 in that top, in that left column in any of them, is switch them. So I'm going to switch row 1 and row 3. And the way you show that is like that, a double-sided arrow. Now remember I said the next goal for me is to get a 0 in that second row first column. How could I do that? Good. Row 1 plus row 2. And I can replace row 1 or row 2 with it, but row 1 was fine. So I'm going to replace row 2. What happened when I add those 2 rows together? That's unique. I got 2 zeros, right? What row do I want to have 2 zeros in though? Row 3, so I can switch row 2 and row 3. I still need a 0 where that 3 is. So now what? How do I get it? Can't do it with the bottom row, right? Got to do it with the top. So negative 3, row 1 plus row 2. And for row echelon, I just have one more step, which is to get this to be a 1. How do I do that? Can I use any other row? No, right? I'll lose the zeros. So what do I multiply negative 2 by to get it to be 1? Negative a half. Okay, now I'm in row echelon. I could take this x minus y plus 4, or sorry, minus 4z equals 14, y plus 13, z equals negative 27, and z equals negative 2. Now I've got my triangle system, and I can use back substitution to solve. I'm going to take the negative 2 and plug it in here. There's the second one. Take them, plug them into the first one. There's the third variable. And there's the solution to your system. Questions on up to that point? Okay, so I'm going to stop here. So we're stopping at row echelon with back substitution, or Gaussian elimination with back substitution. And then on Monday, the video will take you through Gauss-Jordan, which is just finding more zeros and getting it into reduced row echelon. Okay? If you have a graphing calculator, I will show you how to find the solution to the system, but keep in mind, well, I'll just show you what I'm talking about. It could be different. Okay, so I'm going to walk you through the steps to solving a system using a graphing calculator. Keep in mind, you won't do this on this test because I won't give you a graphing calculator during the time of the matrices. But on a standardized test, you want to solve a system, this is how you could do it, okay? 3 variables, 2 variables, it doesn't matter. I'll show you how to set it up. So the first thing you're going to do is there's a matrix button. So it's above the x to the negative 1. I'm going to go second, x to the negative 1, and I get brought up this menu. So the first column there says names, then math, then edit. So the edit is where you're going to insert your matrix. I go over to edit. I'm going to pick the first one. This is just A, okay? And at the top is the order of the matrix. So if I looked at this matrix specifically, it's 3 rows and 4 columns, and I type it in that order. You with me so far? If it was a system with 2 equations, it'd be 2 and 3. Okay, so I do the 3 and the 4, and then I hit enter to advance through each of those. You can arrow down or you can enter. And then I type in all the constants, just like I did the matrix. So it's 3, negative 2, 1, 15, negative 1, 1, 2, negative 10, 1, negative 1, negative 4, and 14. So it matches the matrix. Are you with me so far? Then I get out of that menu. So second, quit brings you back to your home screen. And I'm going to go back into the matrix menu. So second, x to the negative 1. This time I'm going to scroll over to where it says math. So the thing at the top is DET, that's determinant. We're going to get to that later on in the chapter. If you scroll all the way down past the numbers, you get to A and B. A is REF. What do you think REF stands for? Row echelon form. So if I click on REF, right, I get here. Now I have to pull up the name of my matrix. To do that, I go back to that menu. Second, x to the negative 1. The name's there. I entered it in A, so I just hit A. I hit enter. Now it gives me this, right? This is a reduced row echelon form. It's not necessarily the same one that we did because they could have done different operations. The first thing I would do is, yuck, those are decimals that don't round. I'm going to put that in fraction form. So if I go to math, there's that little arrow that says arrow fraction. It's going to take all those decimals and convert it to fractions for me. Now I have a row echelon form that I can use back substitution. So the answer might not look like your row echelon form, but if I solve this system, it will give me the same answer. So notice that z is -2, which matched what we got, right? It would be the same if I did back substitution.
Wait, how'd you get the fraction form?
Hit math, and the very first thing in the line is arrow fraction. Okay, but I could go one step further, get this into reduced row echelon, and it gives me my answer. So if I go back to the matrix menu, second, x to the -1, I go over to math, I go all the way back down again, and there's an REF, which is reduced row echelon form. Hit that, go back to the second matrix menu, hit A, because that's where this matrix is, hit enter, and there's my solution in reduced row echelon form. X is 5, Y is -1, Z is -2. Questions? Again, not something you're going to have on your test because I'm not going to let you have your graphic calculator on your test. However, if you want to check your answers on your homework, this is a great way to do it. If you're taking a standardized test and you need to solve a solution, that's a great way to do it. Everybody good? Yes? Okay. I am going to post a PDF for your homework because WebAssign is kind of wonky on these questions. So you're going to be able to show me the work, and keep in mind, there's a lot of work involved here. If you just give me a system, you're getting nothing back from me, okay? So you need to make sure that you're solving. There's going to be questions that are the easy ones, like, dimensions, that kind of stuff. But on the big ones, and I'm not going to give you a lot of them, but on the big ones, the row echelon form, you need to make sure you're showing all your steps and you're labeling what you're doing because you want to get in that habit. It's so easy to make a mistake here. One little negative is all it takes. So you got to be so careful. Don't rush through it. There's like a saying in Link Root, go slow to go fast. If you rush through it and you get it wrong, you got to redo it. It's going to take longer than if you just do it slowly and correctly the first time, okay? I have no problem with you entering that in the calculator, figuring out what your answer should be and working towards it. You just can't only give me the answer. You got to show me all that work.